Let's start with one of the core concepts in OS, file allocation methods. Whether you're saving a document or your pictures or images or trying to install some game, your OS has to figure out where on the disk your file should go. And that's where file allocation strategies come in. Now, let's start from the very beginning. Every disk is divided into fixed size units called blocks. And when you save a file, your OS has to decide which block to use to store it, how to keep track of them, and that process is called file allocation. Similarly, you can think of it like organizing books in a library. Some books go on the shelf next to each other, some are scattered across different aisles but have notes pointing to the next one. Some have an index card listing every shelf they're on. These are the three main allocation strategies that we're going to explore: contiguous, linked, and index allocation. Okay, here I have a disk with 28 blocks. I have a directory with file names, the starting block, length, and so forth. It's color coordinated between the file allocation with the file name, and this is just for easy visualization. Let's start with contiguous allocation. This is one of the simplest ones. The file is stored in a contiguous block of space. For example, if we have your pic.png, it needs 4 blocks. The OS needs to find 4 blocks in a row, and we're going to start with block 0, and we're going to go to block 3. So this was the location of all of our content when it comes to this picture. So again, this is like storing books on a single shelf. It's very easy to find. This is especially important and easy for sequential access. However, if there aren't 4 free blocks in a row, even if there's enough space scattered around the file can't be stored. This is again due to external fragmentation. And if your file grows and there's no room after block 3, you're pretty much stuck. Okay, let's move on to our next allocation method, and this is the linked allocation. So this method stores the file in blocks anywhere on the disk. Again, this is non-contiguous. And each block contains a pointer to the next one. So for our hello.txt, we're seeing that it starts at block 12. Block 12 is going to have a pointer that's going to be about 4 lengths, so I get to pick out wherever I want. So I'm going to say 12 is going to point to 14, and 14 is going to point to 10, and then 10 is going to point to 15, and we'll say 15 points to 19. So basically each block is going to point to the next one. Very much similar to a scavenger hunt, each clue leads you to the next one. This leads to no external fragmentation. You can use any available blocks. It's easy to grow your files, but you can't jump directly to block, say block 14. You have to follow the link, so it's slower for random access. Now, the last one is index allocation. This one is a special type because you need a special index block, and this index block stores the address of all the file's content. So for us, we're saying that our special index block is 20. So we go into 20, and inside of here, it opens up. We're getting this list of all the blocks that contain the content of cheer.move. So for our toy example, we're saying that you can find it in blocks 21, 22, 23, 24, and 25. That basically means all of this is taken care of. So again, it's like an index card listing where each chapter of your book is on the shelf. It supports direct access. There's no fragmentation. It's also easy to grow. But if you need, but you do need that extra space specifically for the index block. And if your file is massive, one index block might not be enough to store everything. So let's do a little comparison of your allocations and based off of the features. So based on this quick summary, which one is the best? Well, it really depends. For fast access to large files, contiguous might win, but for flexible storage, link might shine. And if you want a mix of both structure and flexibility, maybe looking at the index offers a great balance to that. All right, well, that's a wrap on file allocation methods.